It's a really exciting time to be alive. We have a front row seat to the only known transformation of a world powered by dirty fossil fuels to a planet that gets its energy from renewable, clean sources. It's going to happen just once, right now. These are the top 10 potential energy sources of tomorrow. Number 10. Space-based solar power. Every hour, more energy from the sun reaches us than we Earthlings use in an entire year. To try and save a lot more of it, one idea is to build giant solar farms in space that will collect some of the higher intensity, uninterrupted solar radiation. Giant mirrors would reflect huge amounts of solar rays onto smaller solar collectors. This energy would then be wirelessly beamed to Earth as either a microwave or laser beam. One of the main reasons this amazing idea is still just an idea is because it's, big surprise, very expensive. But it could become a reality in the not so distant future as our solar technology develops, and the cost of launching cargo into space comes way down thanks to the work of companies like SpaceX. Number 9. Human power. We already have human-powered devices, but scientists are working on harvesting power generated from normal human movement. We're talking about tiny electronics here, but the potential when multiplied by billions of people is big. And with developers making electronics that use less and less power, one day your phone may charge when it rustles around in your pocket, your bag, or moves in your hand, or your fingers move on the screen. At Lawrence Berkeley National Laboratory, scientists have even demonstrated a device that uses viruses to translate pressure into electricity. Yes, it's amazing as it sounds, and no, there's no way I'm going to try and explain how it works. Of course, it's linked below if you want more info. There are even small body-worn systems that passively produce electricity when you move. Human power isn't going to solve global warming, but every little bit helps. Number 8. Tidal power. Harnessing all the energy in the motion of the ocean could power the world several times over, which is why over 100 companies are trying to figure out how. Because of the focus on wind and solar, the tidal energy industry kind of got elbowed out of the early mix, but these systems are quickly becoming more efficient. For one, meet Oyster, a 2.4 megawatt producing hinged flap that attaches to the ocean floor and, as it opens and closes, pumps high pressure water on shore where it drives a conventional hydroelectric turbine. One of those could power a whole housing development or a couple massive residential towers, roughly 2,500 homes. An engineer with the Air Force Academy has created the Terminator winged-shaped turbine that employs lift instead of drag, allowing it to theoretically harness 99% of a wave's energy instead of the 50% that current tidal projects can get. And Perth, Australia, just got the world's first ever wave-powered desalination plant that provides the city with enough drinking water for 500,000 residents. Number 7. Hydrogen. The element hydrogen, by far the most abundant in the universe, is very high in energy, but an engine that burns pure hydrogen produces almost no pollution. This is why NASA's powered its space shuttles and parts of the International Space Station with this stuff for years. The only reason we're not powering the entire world with hydrogen is because it only exists on our planet in combination with other elements like oxygen. You know, good old H2O. Russia even converted a passenger jet to run on hydrogen in the late 80s, and Boeing recently tested small planes that fly on hydrogen. Once the hydrogen is separated, it can be pumped into mobile fuel cells in vehicles that are able to directly convert it into electricity. These cars are now being manufactured on a fairly large scale. Honda is planning on demonstrating the versatility of its new hydrogen fuel cell car by plugging it into a model home in Japan to power the house, instead of the car sucking electricity from the building like its electric-powered competitors have to do. Honda says one of these fully fueled cars could power an entire house for a whole week, or drive 300 miles without refueling. The main obstacle right now is the relatively high cost of these vehicles and the lack of hydrogen stations to refuel them. Although California now has plans for 70 of these stations across the state, South Korea is expected to have a total of 43 soon, and Germany is aiming for 100 by 2017. Number 6. Geothermal heat from underground lava beds. The method of converting the heat rising from the depths of the molten core of the Earth into energy, also known as geothermal, powers millions of homes around the world, including the electricity usage for 27% of the Philippines and 30% in Iceland. But an Icelandic deep drilling project may have recently discovered the Holy Grail when it hit a pocket of magma, which had only happened once before in Hawaii. The team pumped water down into the hole, which the scorching magma instantly vaporized to a record-setting 842 degrees Fahrenheit. This highly pressurized steam increased the power output of the system tenfold, an amazing success that should lead to a giant leap in the energy generating capabilities of geothermal projects around the world. Number 5. Nuclear waste. Nuclear fission power plants are the traditional reactors that have been in use around the world for decades and provide the United States with 20% of our electricity. They use something called light water technology to surround the fuel rods with water, which slows the neutrons and allows for a sustained nuclear reaction. But the system is really inefficient. Only 5% of the uranium atoms in the rod get used up by the time it has to be removed. All that unused, highly radioactive uranium just gets added to our growing stockpile of nuclear waste. But now, finally, there appears to be another, more efficient way, called a fast reactor, where the rods are submerged in liquid sodium instead of water. This allows 95% of the uranium to be used, instead of the unacceptably inefficient 5%. Adopting this method would solve the huge problem of getting rid of our 77,000 tons of radioactive waste, because these new reactors can reuse it. GE Hitachi has already designed a fast reactor called PRISM and is shopping it to power companies. But the biggest obstacle is the high cost of building new nuclear power plants. Plus, you have to overcome the political stigma that nuclear is a dangerous energy source. Still, the benefits are huge. It's a proven technology that emits pretty much no greenhouse gases. The big success story is France, who has 75% of its electricity needs met by its 59 nuclear power reactors. Number 4. Solar windows. With production and installation costs getting cheaper by the day, solar power is taking off around the world. Europe is the best in photovoltaics and is driven by its leader, Germany. On an average sunny day in 2012, Deutschland got as much energy from the sun as 20 nuclear power stations, enough to power 50% of the country. Spain is now generating more than 50% of its power from renewable resources like solar. A California desert is home to the largest solar power station in the entire world, and the United States increased its solar capacity by nearly 500% from 2010 to 2014. And if you think that that's as fast as solar can possibly grow, listen to this. Researchers at the Los Alamos National Laboratory in New Mexico just made a significant breakthrough in quantum dot solar cell technology that will allow highly efficient solar panels to double as transparent windows. When this technology becomes cheap enough to hit the mass market in the next couple of years, every sun-exposed window in the world will have the potential to be converted into a mini power station. Number 3. Biofuels. From 2002 to 2013, biofuels grew more than 500% in the US, as production of crop-derived ethanol and biodiesel became a mainstream substitute or supplement to gasoline in our cars. In fact, back in the day when Henry Ford first developed his Model T, he thought it would run on ethanol. The discovery of vast amounts of cheap oil all over the world unfortunately made it the go-to energy source, but renewable biofuels are making a strong comeback now. The only problem is that the currently dominant first generation of biofuels use the same land and resources that have traditionally been used to grow food, which is driving up the cost of food and causing big problems in a lot of the developing world. So something has to change if biofuels are going to give us a chance at replacing oil with something clean burning. That's where a plant like switchgrass comes in. It's hardy, it grows like a weed just about anywhere, and it isn't food. But if we wanted to run all of the world's cars on it, we'd need to plant it on an amount of land equivalent to the entire countries of Russia and the United States combined. So that's not going to work. This brings us to the third generation of biofuels, algae, which has all the right ingredients to replace oil once and for all. Algae's natural oil content is greater than 50%, which means it can be easily extracted and processed. We can convert the remaining parts of the plant into electricity, natural gas, and even fertilizer to grow even more algae without chemicals. Algae grows quickly and doesn't need farmland or fresh water. Just last month, Alabama became the world's first algae biofuel system that can also effectively treat human wastewater. This actually resulted in a carbon-negative outcome. The 40,000 a day demonstration plant basically floated giant bags on a bay, pumped wastewater into them, added a little algae, and then let the sunlight do its thing. Before long, algae had grown everywhere and cleaned the wastewater so well it could either be released back into the bay or reused by people as drinking water. Number 2, flying wind farms. We're already getting a lot of energy from the wind, but with the buoyant air turbine, or BAT, that floats 1,000 to 2,000 feet above the ground where winds are stronger and more consistent, we could soon be getting that energy much more efficiently. The system is simple. A ringed blimp with a wind turbine in the middle is tethered securely to the ground. It'll produce twice as much power as similarly sized tower-mounted turbines. It can even handle winds of more than 100 miles per hour and can be fitted with additional devices like a Wi-Fi unit, which would help bring the internet to parts of the world that don't have it yet. The buoyant air turbine was designed for bringing renewable wind energy to rural parts of the world, where building a traditional wind turbine was impossible, and will first be deployed in Alaska. It can even automatically detect and adjust its floating height to where the best wind speed is. When the wind speed is dangerously high, the thing will dock itself, eliminating the need for manual labor. Flying wind turbines like this should soon replace all the less efficient tower-based systems and could allow for the construction of offshore wind farms that have, until now, been really expensive to build. Number 1, fusion. Unlike fission, nuclear fusion doesn't create any deadly nuclear waste because it fuses atoms together instead of splitting them apart, so there's no threat of a runaway reaction that could lead to a meltdown event. But this is easier said than done. One nuclear prize-winning physicist described fusion as trying to put the sun into a box. The idea is pretty, the problem is we don't know how to make the box. The technical issue is that fusion reactions will produce material that's so volatile and hot it will damage the reactor that created it. This isn't stopping private companies and governments from spending billions to research the technology and solve these problems. And if the immense challenges can be overcome, fusion will provide virtually limitless energy and power the world. That's why the world's wealthiest governments are collaborating on the controversial International Thermonuclear Experimental Reactor in France, known as ITER. When was the last time Russia, China, Europe, and the United States collaborated on anything? That's how important for humanity this project is, and because of its revolutionary potential, several powerful companies like Lockheed Martin are quietly working on their own fusion reactors. Lockheed has a very optimistic timeline for their system, projecting that they will meet global energy demand by 2050. Their optimism may be fairly justified. In October 2013, in separate research, scientists at the Lawrence Livermore National Laboratory in the United States achieved a huge milestone in fusion when, for the first time, a fuel capsule gave off more energy than was applied to it. Thanks for watching. Let us know if we missed anything or if you disagreed with our rankings. And if you liked this video, help the conversation spread by sharing it.